Number 25 on the practice exam. The past several years, when third grade boys at Laie Elementary School were given the reading portion of the wide range achievement test, the mean score was 51. The third grade teachers recently instituted a new reading program and then tested 150 randomly selected third grade boys from Laie Elementary. The sample mean score for the 150 third grade boys is 52.4. At the 0.05 level of significance, test the claim that the mean score has increased. Assume sigma is known to be 13.14. Alright, so the first question you need to be asking yourself is this a z-test or a t-test? Well, sigma is given, and anytime sigma is given, we use z-test. So after we figure out that it's a z-test, let's set up the null and alternative hypothesis. Our null hypothesis, again, it's always that the mean population is true, so and that there's no difference from that mean population. And we are given that mean population mu to be 51 because it says here for the past several years, the third grade boys at Laie Elementary were given the reading portion of the wide range achievement test. And the mean score from those past years has been 51. So those are informations about the population. And then because of this new reading program that they instituted, we want to test out if this reading program is actually changing that mean score. And the change that they want to claim is that it's increasing their score. See this part right here? Test the claim that the mean score has increased. So if we're assuming that there's no difference from the way it was done before, the null hypothesis is 51, but we're testing that it's greater than 51 after this reading program. The alpha level is 0.05 because it's right here. It's given to us. And if it wasn't given to us, remember that the default is always 0.05. All right, we can use the calculator because that's the fastest and easiest, or you can do it by hand. And this is the formula for z-test. But let's use the calculator just to save us some time. Turn it on. Stat, test, and the very first is z-test. All right, you have the option between data and stats. Remember, stats, you use stats if you put all of your information in the lists. But because we didn't put anything on the list, we use, actually, that's the opposite. Data is when you put everything on the lists. And stats is when all the information is given to us already. So because we don't have anything on the list, we'll use stats. Our mu naught is 51. Our sigma is 13.14. It's given to us right there. Our x bar is 52.4. And then the sample size, they selected 150 randomly selected third grade boys. And then again, we're testing the claim that this new reading program is improving the score. And then we'll calculate. There it is. Our z is 1.30. So if you just put 1.30 in your test, then you're set. You don't really have to show very much work. We all know, and we all taught students that to use a calculator. So all you have to show is this. Just make sure you're right. And then the p-value is 0.09. And then, very important, the decision part. So are we rejecting or failing to reject? So because 0.09, comparing it to 0.05, 0.09 is greater than 0.05. And whenever that's the case, when your p-value is greater than your alpha, you fail to reject. You can't make any conclusions. So when you write the conclusion, you say not sufficient evidence to support the claim. This claim that the mean score has increased. So based on all of this, we cannot conclude that this reading program has improved the mean score. And that's it for number 25.